Good morning to one and all. This is Padmavati. I'm working in Department of Computer Science in Sri Venkateswara College of Engineering, Bangalore. Today we are going to discuss a topic on digital image processing, and the topic is image compression model. So basically what this image compression model is done, we are going to see. And here there are various techniques are used for compressing the amount of data which is required to represent an image. And here for compression models, we are using image compression systems, which carries the overall characteristics of a system and it develops a general model to represent it. So here we can take f of x comma y, which is an input image, which is fed into the encoder, which creates a set of symbols from the input image. After the transmission over the channel, the encoded representation is fed into the decoder, and where the reconstructed image, which is called as f dash of x comma y or f cap of x comma y is generated. So in general, f cap of x comma y may or may not be an exact replicate of f of x comma y. It may be same or it may not be same. And here there exist two characteristics. If f cap of x comma y is exactly equal to f of x comma y, then there is no error. That means the system is error free and the information have been preserved. And second condition is, if suppose f cap of x comma y is not equal to the exact replica of f of x comma y, then there will be some distortion present in the image. And here we can see the encoder is made up of, this is nothing but the encoder and this is nothing but the decoder. And here the encoder is made up of source encoder, which removes the input redundancies, and the channel encoder, which increases the noise immunity. That means it reduces the noise of the source encoder output. And here we have a decoder, which includes channel decoder as well as the source decoder. See, in general thing, we will be having decoder only, but inside decoder, we will be having a channel decoder and a source decoder. So here the channel decoder is followed by the source decoder. If the channel between the encoder and the decoder is noise free, that means there is no error. Then the channel encoder as well as your decoder are omitted, and general encoder and decoder we can take as source encoder and source decoder. Here the source encoder is responsible for reducing or eliminating any kind of coding. That means coding redundancy, interpixel redundancy or psychovisual redundancy in an input image. So the specific application that is associated with fidelity requirement, it dictates the best encoding approach to use in any kind of situation, and the approach can be modeled by three independent operations, and each operation is designed to reduce one of the three redundancies. In the first stage, the source encoder is usually has a mapper. See here, it has a mapper and it has a quantizer, and then it has a symbol encoder. So we are giving the f of x comma y, that is our input image. See the mapper, what it does, it transforms the input data into a non-visual format, which is used to reduce the interpixel redundancy in the input image. The operation is just reversible in terms of your decoding process. So first what we are doing here, interpixel redundancy will be reduced, and here in quantizer your psychovisual redundancy is reduced, and in symbol encoder the coding redundancy is reduced. So these three redundancies have been filtered here, and thereby when we are giving f of x comma y, that is our input image, then our output will be very clear with all three these redundancies. So once this redundancy is clear, then it is transferred to the channel, and where your channel has been given to the channel decoder and source decoder. So whatever the process we are doing in the transmitting side, the reverse process will be done in the receiving side. The same compression also, for example, here I'm giving 1024 cross 1024 size of image. So what it does, the compressor, what it does, it reduces the size to 512 by 512. That means it is just reduces it to half of the size, and then it transmits over the channel, and then it just does the decoding process. And after that, the size will be increased to 1024 to 1028 to 1028. So what happened actually, here also the size of the image is large, and here also the size of the image is same. But in between we are compressing, and here we are decompression. So here after giving, the image is compressed and the data will be sent to the channel, and then here the size of the image is decompressed. So there will not be any loss of data from the source to the destination. So the same process has been done in the general compression system model. So whatever the information we are giving, that will be compressed and it transmit towards the channel. And after it transmit towards the channel, it reaches the receiver side. And once it reaches the receiver side, again it is decompressed. And through the general compression system, we can reduces most of the image redundancies, and this channel is used for storage purposes, and this reduces the impact of channel noise by means of adding some kind of protection bits, which is called as extra bits. And here the reverse process of encoder has been done. So this topic completely covers the general compression system model. Thank you.